Yeah. Yeah.
You're not allowed to be scared at graphs just because you see a graph.
Yeah, we are.
Nope.
Fear is a.
Okay.
Some graphs are others.
Lesson 4.1. Using graphs to relate two quantities. Now, you'll notice in this lesson there are several problems copied in, and that was kind of the easiest way to get through it, right? Okay, so just follow along. Robbie, put the iPad up so you're not tempted to be distracted, please. Okay, so as we look at this first getting ready example. Oh gosh, those copied poorly.
Yeah.
Okay, well,
I can
that's
barely
all right.
see it.
I would say I didn't realize that
Even on the paper.
There's no
it's like,
mistake.
Hey.
I didn't realize how poorly these copied, but can you see this?
Yeah.
I may have to move up.
Well, those are in your notes if you look carefully.
I mean,
Okay.
you can kind of see the lines.
Yeah, they're in your notes if you look carefully. I mean, I can see them if I look carefully. Now, the graphs below relate the height of the water to the volume of water in each container. Which graph goes with which container? Justify your reasoning. So, we have a graph here that as the volume increases, height is increasing. But of course, notice that it starts to slow down. Over here, as volume increases, height increases at a slow rate. Over here, as volume increases, height increases at a steeper rate. Thoughts of which ones match up with which ones?
The first one matches up with that first box with the curvy line.
The middle one.
The first graph
Yeah, the first.
with the which container?
Middle one.
Hold on. Disagree.
The light.
This right here, yes?
Yes.
Okay. Container 1, 2, or 3.
3.
I can agree with that. Okay? Because what's happening? As this object is getting taller, right?
Yeah.
So as this object is getting taller, the volume, how much it holds, is increasing. And it's increasing at a steady rate. Until what happens when this container gets wider?
It widens.
It widens, but my volume, how much it's holding is it's slowing down. Okay?
Yeah, because the bigger it is, the longer it's.
Yep.
And the second box goes to the first thing, and then the last box.
Okay, wait, hold on. Give me one here. The second graph goes with what?
The first one.
And that's because as the volume's increasing, the height is slowly increasing, right?
Yeah.
You've got a slower piece. And then that leaves this third graph to go with.
This the Red Bull. We'll call it Red Bull.
Okay. The second container. And this is more, as your height is increasing, the volume is increasing quickly, right? It's going up quickly. Okay, so those are some of the things we want to be able to look at. Now, in problem 1, I apologize, guys, you have to read words with me today. I know it's math class. You have to read words with me.
Okay.
Okay? You're just going to have to deal with me. Robbie, you still with me? You can't fall asleep yet. You got to give me some of your time at least. Okay. The graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? And describe how the variables are related at various points on the graph. So one of the things you have to do is be able to pull out the variables. Now, as we talk about that, what do I want to do here? The variables, where do we find the variables on the graph? Where are the variables here? What are the two things that are changing?
The time and the volume.
Time and volume. So right here, the variables are volume and time. Okay, those are the two things that are changing. As time is increasing, what's happening to the volume? The balloon is the volume of the balloon. So how much air the balloon holds is increasing because we are blowing the air into it. Now, okay, so what's happening?
It's going up.
Okay, as time's passing right here,
And it curves.
we're going up, yes?
Yeah.
So as time's passing, I'm blowing air into this balloon. The balloon's getting bigger. What about right here? Why is it flat there?
It's a breath.
Take a breath, right? What happens when you take a breath? Is the volume still increasing?
No.
No. The volume pauses, right? And then what happens here? We're blowing more air into it, right? We pause and take a breath, blowing more air into it. Pause, take a breath, blow more air into it, and what's that sudden drop?
Let it go.
I let it go.
No. Did you listen to the problem when we read it?
No.
The graph shows the volume of air in a balloon as you blow it up until it
Pops.
I said
pops.
this.
The volume goes from being way up here to nothing because the balloon pops.
How fast is a balloon?
Yeah, that's a good question.
To me, it's instantaneous. I mean, it just happens in an instant.
Yeah, there has to be like a actual.
So, okay. So right here, the explanation's already written here. The volume increases each time you blow, stays constant each time you pause to breathe, and when the balloon pops in the middle of the fourth breath, the volume decreases to 0. Okay? Those are the kind of connections we need to be able to make with these graphs today. Okay, let's go to the next one, where I think we have to actually figure it out.
Oh, let's go.
Okay. A.
Wait, that's different. Is it?
Don't turn the page. You're not turning your page.
Oh, I'm a dummy.
I did not mess this up yet, okay? We're still good. Now, what are the variables in each graph, and describe how the variables are related at various points on the graph. So, example A. First of all, what are my, I'm just going to write it over here. What are my variables on that graph?
Time.
Time and length, right? The two different labels, put it up, put it behind you. Okay, the two different labels on your axes. So my variables here are time and length. Now, how are the variables related? So notice it's the board, length of a board, right? Think about this. As time is increasing here, so as we move right on this graph, what's happening to the length of the board? It's what? It's getting smaller, right? My board is getting shorter. Why is it? Because if you look here, it's the same length, right? It stays the same length, and then what happens? It drops. Stays the same length, drops. Stays the same length, drops. Stays the same length. How is that happening? What's the situation that's happening here?
It's going up and down. It's jumping.
Not going up and down. Board length, it's the same here as you go horizontal, because that's not going up or down, it's the same. Then all of a sudden it drops. So now my board is shorter. Then it drops. My board is shorter.
Wait, what kind of board are we talking about?
This is where you need to
getting
figure out the
cut.
situation.
It's getting cut like a
Is
circular
it getting
something.
cut?
It's like a 2x4.
Okay. And that's the thing. When it gets cut, a cut just happens all of a sudden you finish cutting, right? But does it take you a while to cut through?
Yeah.
Yes.
Yeah, if you're sawing or however you're cutting this board,
Good 10 seconds.
that, right here, we're sawing. Then all of a sudden, we finish that cut, and the piece drops off, and now here again, we're sawing, so the board is the same length, and then piece drops off. Does that make sense? So that's what you need to be able to do here, is kind of read into the situations. And so I'm going to say, I'm just going to kind of explain this a little bit. Length of board. I'm going to say remains constant while, I'm going to say sawing, or you could say cutting. And then length decreases when a piece is cut off.
You want us to write that?
It's up to you. I mean, in Math Excel, it's going to be more about trying to identify a description, probably. And I don't think the homework's not too long, if I recall. Okay? But it's about being able to explain a situation. Okay? Put words behind it.
After we get this next one, then
Do you have any bathroom passes
yeah.
left? And is it an emergency? Because I'd really rather you not go during the lesson.
Yes, I have two.
Okay. Okay, let's look at B. Notice June's cell phone cost. What are my variables?
Calls and what's that? I can't read.
Cost.
Cost.
Cost? You have it on the paper in front of you.
Oh yeah, true.
Okay, so my variables. In other words, the two items changing here.
I already have a story.
You already got the story?
Yeah.
Minutes of calls and cost. Now, and I will caution you guys that you have to think old school on some of these because these are older examples.
Yeah.
So they don't necessarily go with, I don't know, they don't always go with current technology type, And maybe it's, Okay, so now we've got to describe how minutes of calls. So notice as I move right, as my minutes of calls
It's flat.
are increasing, the cost is, what is it? When it's flat here, the cost is just staying the
Staying the same.
same. And then what
And
happens?
then you run out of minutes and they jack your stuff up.
I don't think it's how it works. Okay.
That is how it works.
So, and I don't know what your current, in all honesty, how much you guys even talk on the phone.
Not that much.
Exactly. It's more about texting than,
Do they
anything.
even
But
do that anymore?
I honestly don't know.
On some, if you like
You
go to
want
Walmart,
minutes? Yeah.
but it's only like.
Like a prepaid. Yeah. I don't know. But so the idea here is you're talking, you're using your minutes, and you're using basically your included minutes.
Yeah.
You run out of included minutes, and now
All of that.
your cost increases because you have to pay per minute all of a sudden.
Yeah.
Okay? Or in Robbie's terms. They jack you up because they make you pay a lot. Okay. So I'm going to say the cost, and I honestly don't know what, I don't know. We never use anywhere near that many minutes that it matters.
No, you gotta.
I think minutes are unlimited on a lot of planes
Yeah, they
now, though,
are.
too.
Yeah, that's what I got.
Just kind of like texting is unlimited and all that. So,
Didn't you used to have to pay to text? Like,
oh yeah.
when you text, you had to, like,
I used to hate when someone would text me back when some people started to have unlimited texting and I still paid per text.
yeah.
And or I'd have so many included texts and then I'd have to pay per text. And people would text back, okay. And I'd be like, I don't need you to know okay. Like, don't text, But, okay. So I'm going to write here, and I don't know if you guys are writing this down. I would encourage you to, but cost, remains constant. While under minutes, and then I'm going to say cost increases when you go over your minutes. Okay, so you've seen these kind of graphs before, right?
Yes.
This isn't anything new.
We
You're
learned
kind of
this-
seeing the relationship here.
We learned this.
Okay, one more example here. I don't think you learned it in kindergarten, but the graph below shows the amount of gasoline in Jamie's car after she fills up her tank. What are the variables and describe how they are related at various points on the graph? Okay, so first of all, hey now, watch out, your teacher's a girl. Okay, what are my variables?
What? But oh, variables are time and days and gas and gallons.
Okay.
Yes.
So I'm going to say my variables, I'm just going to put time and gas. Focus, Mr. Height. Yes, focus. Now, okay. So we need a description here. As time is increasing, as your days are increasing, what's happening?
Okay, so
Lose more gas.
yeah, but you fill up. Okay, it costs you $100.
Today it does, yeah.
And you
That's cheap now.
Okay, so right here, that's where she fills up, right?
yeah.
She fills up like on day 0 or day 1.
Yeah, and then she goes to work. That costs some gas
Okay,
throughout the week. Whatever you need.
okay.
Gas.
And so if you look, like right here, she maybe didn't drive much, did she?
No.
No,
But then all of a sudden, drives a bunch.
she went on vacation.
Okay. Then here, I don't know about when on vacation. This is just 1 tank of gas here. Then here, it's flat. So didn't drive anywhere, right? Didn't maybe go anywhere that day. And then it's decreasing, right? So each time it's decreasing, she's using gas. Each time it's flat or constant, she's not using gas.
And her mile per gallon is good.
That's what I'm saying.
So I'm going to say,
Like I was.
as days pass,
20-year-old diesel truck is a really good idea.
as days pass and she drives, gas decreases. And then I'm going to say gas remains constant when not driving. Okay, write down what you want on that one.
Yeah, 21-year-old diesel truck with 35 is probably not a good idea to drive right now.
Did you know those smart cars only have 3 lug nuts? My golf
Gentlemen.
cart has more lug nuts than that car.
Okay, did you guys get what you needed here?
Yeah.
Let's look at the next problem.
I go to the bathroom.
Sign out and make it super quick. Okay, problem 2 here. It's a multiple choice problem, so you guys should like it, right?
Yeah, these are little bad.
Okay. Hey, keep in mind, Math Excel is going to be some multiple choice, so that will be nice. Okay. A band allowed fans to download its new video from its website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table?
B.
I say A.
It's definitely B. Because it's not going straight up. It goes a little.
Oh yeah, he has
Way
way.
more and then way up there.
So he's right. Wherever he is, he's right.
Definitely B.
It definitely does not have constant changes.
Because it's definitely not C or D.
What if it was
B.
Okay. So a couple of things to point out here.
It's not going down, so it can't be B.
I would say what ones can we rule out? That's always a good place to start here.
B and D.
Okay. Why are we ruling D out?
Because it's going straight down when it's going up.
Okay. That's saying that each day there are less downloads. Is that true? No, each day there's more downloads. So D is an automatic no-go.
Same with C.
Now, what's wrong with C?
It
goes
goes
up.
up and goes back down. When it
It goes up, but it evens out.
Okay. And so this is where we kind of need to look, and I'm just going to estimate. There's 346 to 1,100. So if we say 300 to 1,000, that's increasing by approximately 700.
Yeah.
And then 1,000 to almost 3,500. And that's going to be increasing by 2,500. And then here, 3,500 to 10,000.
Going up 5 months.
That's going up by about what? 6,500, I think. Nope. Try again.
95. I mean 75.
Well, if I'm going 3,500 to 10,500,
So
about 7,000. 7,000, 6,500. Now, here's the deal. Each time it's increasing by a lot more, isn't it?
Yeah.
So if each time it's increasing by a lot more, well, you guys ruled C out because C, it's starting to flatten out. This definitely is not flattening out. And we ruled A out because
It's not going straight up.
A is constant. A would be, okay, we added 700 the first time, we add 700 the second time, we add 700 the third time, we add the same amount each time. And so that does take it back to B. Okay?
See, there's one.
Okay. Next example.
Okay, I'm gonna say my guess is
My guess
A,
is,
C. Let's guess C.
I'm going to read the problem real quick.
A. It's definitely A.
The table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. So after 0 uses, there's 5 ounces. After 1 use, there's 4.8 ounces.
They're going by
After 2 uses,
0.2.
there's 4.6 ounces. Why are you on your phone right now?
I'm texting broke.
Okay, no, put your phone up.
I have to text broke. I'm allowed to.
I don't have anything saying that. I don't even know who Brooke is, and I'm in the middle of.
Fort County. That's all I'm saying. I'm listening. I can double task.
Okay, we're gonna have a conversation about this at the end of class. Because I have nothing that says you get to randomly just get on your phone in the middle of class and text someone. No one in here has that right. Send your text, and I want your phone back in the back. Because I'm trying to teach a lesson here, and that's where we need to be.
It's down by 0.2.
Yeah.
Okay.
It's right now.
So
Rylan has a point.
notice 0, 1, 2, 3 uses, 5 ounces, 4.8, 4.6, 4.4. And each time it is going down 0.2, isn't it?
Yeah, Rylan has a good point.
And what was Ryland's point?
It's constant.
Okay, it's constant.
So the A has to go straight down.
But C does too.
No, C's not constant. It's flattened out.
Not
We're just doing the same each time.
I would say that A and C are both constant because they're both, I mean, like I can connect a dot or I could draw these and connect them in a line, right?
Yeah.
And I could connect those in a line.
You got a ruler?
My lines aren't very good, but you know. Now, so are you saying B is a no-go?
No.
Okay, B is a no-go because it's not,
C's
Constant.
definitely curved.
No. It's got a constant, but if you look at it, it's got more of a graduate, is that the word?
gradual.
Gradual incline instead of A where it goes further down because it's going at a 2-point rate when then it would be going down more gracefully.
There's definitely a reason that I would pick what I would pick between A and C that I haven't heard you guys say here.
Well, I mean, if you
It's
Never
a
mind,
slight-
because it doesn't hit 0.
It's a slight change.
No,
Do you
it doesn't
notice?
hit 0.
That too.
Where does A end?
At 0.
A says that there are 0 ounces left. Is that true?
No.
No,
9 yet.
that's not true. So that means we have to pick
see,
C. So even though Ryland's eyes don't agree with me that that's
It
constant,
doesn't look constant.
I mean, it
Well,
doesn't
I wear
look, it
glasses.
looks curved, but
don't get too nitpicky here,
it's
okay?
an illusion.
Okay, moving on. We've got another multiple choice here. Table shows the total number of customers at a car wash after 1, 2, 3, and 4 days of its grand opening. Which graph would represent the data shown?
I say A.
Well, B and C are definitely out because it doesn't go down.
Yeah, it's
Which ones are out?
B and C.
C and D.
Oh, C and B.
Okay. I can agree that C and D are out
But no.
because they are decreasing. And what are these numbers doing? They are definitely increasing, right?
Yeah.
Now, and this is where it helps to kind of look and see how much are we increasing by. From 60 to 125, that's around 60 there. 125 to 170, I don't know, is that around 50?
Isn't it 59? Hold on.
How about 52?
Yes, I'll take.
Yeah, and I was just estimating. 177 to 242, so I was just, that's about an increase of 70. So it's kind of up and down a little bit, isn't it?
Yeah, so it's 8.
Okay, I'll
Okay. Here, a little bit more of an increase, less of an increase, more of an increase. Whereas this one is more, less, and less.
Solid, yes.
And so we do want to pick A on that one. And this, I'm just trying to give you guys some ideas of things you need to look for.
This is a big unit.
As I say, we do have 2 more problems to look at.
You know, I was just thinking about where he is.
Okay. Problem 3. A model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during each flight? Label each section. So this graph's already done. But this just kind of shows you the idea. A model rocket, it rises quickly, and then it kind of slows to a stop. So it hits that high point, and it stops right there.
Did you skip a page?
No,
No.
we already did the back. We're on the front, the next front.
Dang, you guys did the back quick.
You were gone a while.
I was going 5 minutes.
No, you wasn't.
No, you wasn't.
7 at the most.
No.
Okay, regardless, if you have to go to the restroom during my class, you get there, you get back. Now, it stops here, so that hits its height. And then at first it's falling quickly. The parachute opens, and it falls more slowly. Okay, let's talk about 3A right here.
Why is he?
Okay, suppose you start to swing yourself on a playground swing. You move back and forth and swing higher in the air. Then you slowly swing to a stop. What sketch of a graph could represent how your height from the ground might change over time? So, here's my graph. Now, what are they wanting us to graph? What are we looking at?
Wouldn't it be like a E?
Height.
We're talking about height, right?
Yeah.
Your height over time. So time is always on this bottom axis. Yes, time is always along the bottom axis. So if time is one of your variables, always expect it to be on the bottom, because that's an independent variable. We can't affect how time changes. Okay? We have no effect on time. Time just
Does it stay?
height, we can affect height. And as time goes, we can affect, height. Now, so it's your height from the ground. So what happens as you're swinging?
And it goes
Up gradually.
it goes up and then it goes back down.
Or you could stay at a constant, rate of. I'm trying to be technical here.
Does your height stay constant as you swing?
No.
No, but there's
No.
that time where you could possibly go in at that for a second, and then
Okay.
it could change.
So your height starts here, right? Then what happens?
It goes up.
It goes up.
Wait.
What happens? As you think about this, you're going to swing, right?
Yeah.
Here's swing. My pin is
Nothing
swinging.
like that, right?
So my pin is swinging.
Down, up, down.
And no, we start low. So if you
Yeah,
swing
that's
forward, we're going to be high. Then we go back down low, and then we swing to the back,
Oh.
and we're going to be high.
Oh.
And then I'm going to swing forward again. So we're going to go low, high.
So wait, so
One time close.
Are you seeing what I'm saying here?
Yeah.
I mean, it can.
Your height starts low, but it goes
Up.
high, low, high, low.
So
Now, as you start swinging faster
it flips.
or higher, as you start swinging higher, it's going to get a little higher each time, right?
Yeah.
So if I start here I'm going to go up, come down. I'm going to go up a little higher because each time you go a little higher, right?
Yeah.
And we're going to go up a little higher. And then eventually what happens?
It just starts going back down.
You start slowing down. Does that graph make sense to you?
Yeah, it's like a swing.
Okay? Because it's not just, you're not graphing the swing, you're graphing the height. And notice, I didn't put it quite all the way at the ground, because technically, are you at the ground?
No.
No, you're a little above the ground, maybe. Okay, one more. Do I have time for one more? We'll try.
So,
If not, you guys have gotten a good idea today, right?
Yeah.
I mean, we've done lots. You've gotten the idea. Okay. When Malcolm jogs on the treadmill, he gradually increases his speed until he reaches a certain level. Then he jogs at this level for several minutes. He slows to a stop and stretches. After this, he increases to a speed that is slightly lower than before, jogs at this speed for a while before slowing to a stop.
Directions for your afternoon announcement.
Hold on, because I want to talk
Back
about
from
this.
spring break, everyone. There is a school Easter egg hunt. Easter eggs are hidden throughout the middle school and high school. If you find one, return it to the library for a prize. Happy hunting. With the following students, please report to the high school office. Jonathan DeWeese, Kieran Celia, Landon Hale, Jason Archer, Connor Gunlight, Jimmy Rincon, Michael English, Tate Streeben, Mason Yeagley, Colby Wyrick, Augie Mueller, Aiden Salisbury, Autumn Hurt, Ariana Jankoviak, Layla Keith, Natalie Newcomb, Ethan Trageser, Peyton Gillum, Colby Wyrick, Leighton Henderson, Drake Ranzier, Tanner England, and Peyton Gillum. Have a great day, everyone.
Oh, shoot. That's not what I wanted to happen. Ah. Okay, guys, real quick. I want you to think through this with. They're talking about Malcolm's speed here, right?
Yep.
Okay, so notice, what did I put on my bottom axis?
Time.
Time. And then we're graphing his speed. So, what's he do first?
Goes speeds up.
He gradually increases for several minutes. So how are we going to show him increasing?
It goes up.
gradually.
Something like that, right?
Yes.
Then what's he do?
Goes down. Stop.
No, he reaches a certain level, then he jogs at this level for several minutes. So what's that going to be?
Up straight up.
Straight across. Then what's he do?
He slows down, so
Slows to a stop. Is that instant?
no, it goes down.
It's going to go down. It goes all the way to the end because he goes to 0. He stretches. What's his speed while he's stretching?
No.
None, so like a horizontal here. Then what's he do?
Go back.
Increases to a speed slightly lower than before. So,
Go higher than that.
right, I'm going to increase, but I'm going to stop lower than before. He jogs at this speed for a short while before slowing down again.
I remember this one. I honestly do remember this one.
You can randomly remember it. Okay, guys. Homework, I don't remember how many questions it is, but I don't think it's too bad. Lesson 4.1 in Math Excel. Do it for tomorrow.
Good.
Okay? And I managed to get through that. Kind of.